let's discuss ground fault circuit interrupter, or GFCI, protection and three-way switch requirements based on the National Electrical Code, or NEC. Specifically, we'll address the application of NEC Section 210.8 concerning GFCI protection in certain areas, and Section 210.73 regarding lighting outlets in storage or equipment spaces such as basements. NEC Section 210.8 mandates GFCI protection for 125-volt, 15-amp and 20-amp receptacles installed in crawl spaces and unfinished basements. The key here is understanding the definition of an unfinished basement. A space may not be considered a basement if it is above grade and framed or studded out for future use as a bedroom and bath. However, the presence of a slab can influence this determination. If a level is on a slab, it might be considered a basement-like space, even if it's partially above grade. This interpretation would then trigger the GFCI protection requirement for receptacles in that area. It's important to note that the type of foundation, whether it's a slab or another type, doesn't automatically exclude a space from being considered a basement for the purposes of 210.8. This section applies to both crawl spaces and unfinished basements, regardless of the foundation. Now, let's move on to the three-way switch for basement stairs. NEC Section 210.73 addresses lighting outlets in storage or equipment spaces, including basements, attics, underfloor spaces, and utility rooms. This section requires at least one lighting outlet containing a switch or controlled by a wall switch in these spaces when they are used for storage or contain equipment requiring servicing. Importantly, at least one point of control must be at the usual point of entry to these spaces. In a basement with only one entrance, the usual point of entry would typically be the top of the stairs. In this scenario, a single switch at the top of the stairs can fulfill the requirement of 210.73. This means a three-way switch might not be strictly necessary to meet the minimum code requirement if the basement only has one entrance. However, it is always best practice to install a three-way switch to ensure safe egress from a basement, especially in the event of a fire. To summarize, the determination of whether GFCI protection is required in an in-between level depends on whether that level is considered an unfinished basement according to the code. The presence of a slab can contribute to this classification, even if the level is partially above grade. As for the three-way switch on the basement stairs, a single switch at the usual point of entry, which is typically the top of the stairs in a single entrance basement, can satisfy the NEC requirement. Remember that local interpretations and amendments to the NEC can vary, so always consult with your local electrical inspector or authority having jurisdiction, or OJ, for specific guidance on code compliance in your area. It is vital to carefully review the specific wording of the relevant NEC sections and any local amendments to ensure accurate interpretation and application of the code. Electrical codes are in place to ensure safe electrical installations. Let's look deeper into ground fault circuit interrupters, or GFCIs, and their role in electrical safety. A GFCI is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault. Ground faults occur when electricity strays from its intended path and flows through an unintended conductor, like a person. GFCIs work by monitoring the difference in current between the hot and neutral wires in a circuit. Under normal circumstances, the current flowing through these wires should be equal. If a difference of even a few milliamperes is detected, it indicates that current is leaking somewhere, potentially through a person who is in contact with a grounded object in an energized part of the circuit. When a GFCI detects this imbalance, it quickly trips, interrupting the flow of electricity and preventing serious injury or electrocution. The trip time is typically very short, on the order of milliseconds, which is fast enough to prevent significant harm. The NEC mandates GFCI protection in various locations where there is a higher risk of electric shock, particularly in damp or wet environment. These locations include bathrooms, kitchens, garages, outdoor areas, and, as we discussed, unfinished basements and crawl spaces. The specific requirements for GFCI protection can vary depending on the edition of the NEC being used and any local amendments that may be in place. It's always important to consult the latest version of the code and local regulations to ensure compliance. Now let's explore the installation and testing of GFCIs. GFCIs are typically installed in place of standard electrical receptacles or circuit breakers. GFCI receptacles have a test and a reset button on the face of the device. The test button simulates a ground fault, causing the GFCI to trip. This allows you to verify that the GFCI is functioning properly. The reset button is used to restore power to the circuit after a ground fault has been cleared. It is recommended to test GFCIs monthly to ensure they are working correctly. To test a GFCI receptacle, simply press the test button. The GFCI should trip, cutting off power to the receptacle. You can then press the reset button to restore power. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. GFCI circuit breakers provide GFCI protection for an entire circuit. They are installed in the electrical panel in place of standard circuit breakers. GFCI circuit breakers also have a test button that should be used to verify proper operation. When a GFCI circuit breaker trips, it can be reset by moving the breaker handle to the off position and then back to the on position. If a GFCI trips frequently, it could indicate a ground fault in the circuit. In this case, it's important to investigate the cause of the tripping and correct the problem before resetting the GFCI. Common causes of GFCI tripping include faulty appliances, damaged wiring, and moisture in electrical boxes. Now let's delve deeper into the NEC requirements for lighting outlets in storage and equipment spaces, specifically focusing on basements. As mentioned earlier, NEC Section 210.73 mandates at least one lighting outlet containing a switch or controlled by a wall switch in these spaces when they are used for storage or contain equipment requiring servicing. This requirement ensures that occupants can safely navigate these spaces and perform tasks such as storing items or servicing equipment. The lighting outlet must be located at or near the equipment requiring servicing. This ensures that the equipment can be easily seen and accessed. The switch controlling the lighting outlet must be located at the usual point of entry to the space. This allows occupants to turn on the light before entering the space, preventing accident. In a basement with only one entrance, the usual point of entry is typically the top of the stairs. However, in a basement with multiple entrances, the usual point of entry may be less clear. In this case, it's important to consider how the space is typically used and what occupants are most likely to enter the space. The switch should be located at the entrance that is most frequently used. While the NEC allows for a single switch at the usual point of entry in some cases, it's often preferable to install a three-way switch. A three-way switch allows the light to be controlled from two different locations, such as the top and bottom of the stairs. This can be more convenient and safer, especially in larger basements or basements with multiple entrances. The installation of three-way switches is governed by specific wiring configurations. These configurations involve using traveler wires to connect the two switches, allowing either switch to turn the light on or off. It's important to follow the correct wiring diagram to ensure that the three-way switches function properly. In addition to the NEC requirements, local built-in codes may also have specific requirements for lighting in basements. These requirements may include minimum light levels, emergency lighting, and other safety features. It's important to consult with your local building department to determine the specific requirements in your area. Electrical work can be dangerous, so it's important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on any electrical wiring. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it's best to hire a qualified electrician. An electrician can ensure that the electrical work is done safely and in accordance with the NEC and local building codes. In conclusion, understanding the NEC requirements for GFCI protection and lighting outlets in basements is crucial for ensuring electrical safety. By following the code and taking appropriate precautions, you can help protect yourself and others from electric shock. Also, consider the importance of arc fault circuit interrupters or AFSIs. AFSIs are designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when damaged or deteriorated wiring creates unintended electrical discharges. These discharges can generate intense heat, which can ignite nearby combustible materials and cause a fire. SIs work by monitoring the electrical current in a circuit and detecting the unique characteristics of arc faults. When an arc fault is detected, the SI quickly trips, interrupting the flow of electricity and preventing a fire. The NEC mandates SI protection in various locations, including bedrooms, living rooms, and dining rooms. The specific requirements for SI protection can vary depending on the edition of the NEC being used and any local amendments that may be in place. It's always important to consult the latest version of a code and local regulations to ensure compliance. SIs are typically installed in place of standard circuit breakers in the electrical panel. SI circuit breakers have a test button that should be used to verify proper operation. When an SI circuit breaker trips, it can be reset by moving the breaker handle to the off position and then back to the on position. If an SI trips frequently, it could indicate an arc fault in the circuit. In this case, it's important to investigate the cause of the tripping and correct the problem before resetting the SI. Common causes of SI tripping include damaged wiring, loose connections, and faulty appliances. It's also important to understand the difference between GFCIs and SIs. While both devices protect against electrical hazards, they protect against different types of hazards. GFCIs protect against ground faults, which can cause electric shock. SIs protect against arc faults, which can cause electrical fires. In some cases, both GFCI and SI protection may be required in the same location. For example, the NEC may require GFCI protection for receptacles in a bathroom and SI protection for the circuit serving the bathroom. In these cases, a combination GFCI/SI circuit breaker can be used. This type of breaker provides protection against both ground faults and arc faults. When working with electrical wiring, it's important to use the correct type and size of wire for the application. The NEC specifies the allowable ampacity of different sizes of wire. Ampacity is the maximum amount of current that a wire can safely carry. The ampacity of a wire depends on its size, insulation type, and the ambient temperature. It's important to select a wire size that is large enough to handle the expected load. Using a wire that is too small can cause the wire to overheat and potentially start a fire. The NEC also specifies the types of wiring methods that are allowed in different locations. Wiring methods include conduit, cable, and raceway. The choice of wiring method depends on the application and the environment. For example, conduit may be required in locations where the wiring is exposed to physical damage. Cable may be used in locations where the wiring is concealed. When installing electrical wiring, it's important to follow the NEC guidelines for spacing and support. Wires must be properly supported to prevent them from sagging or coming into contact with other objects. The NEC also specifies the minimum spacing between wires and other objects, such as pipes and ducts. Additionally, understanding voltage drop is important in electrical circuits, especially in long runs of wiring. Voltage drop is the decrease in voltage that occurs along a wire due to its resistance. Excessive voltage drop can cause appliances to malfunction or not work at all. The NEC provides guidelines for limiting voltage drop in electrical circuits. To minimize voltage drop, it's important to use the correct size of wire for the length of the run and the expected load. Increasing the wire size will reduce the resistance and decrease the voltage drop. It's also important to ensure that all connections are tight and secure. Loose connections can increase the resistance and contribute to voltage drop. Also, always ensure proper grounding. Grounding is an essential safety measure in electrical systems. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and energize the circuit. This helps to prevent electric shock and equipment damage. The NEC specifies the requirements for grounding electrical systems. All metal enclosures, such as electrical panels and equipment housings, must be grounded. Grounding electrodes, such as ground rods or water pipes, must be used to connect the electrical system to the earth. Also, consider surge protection, as electrical surges can damage sensitive electronic equipment. Surges can be caused by lightning strikes, power outages, and other events. Surge protective devices, or SPDs, are designed to protect against electrical surges. SPD divert the surge current to ground, preventing it from reaching the equipment. The NEC recommends the use of SPD in various locations, including service entrances and branch circuits. SPD can be installed at the service entrance to protect the entire electrical system. They can also be installed at individual branch circuits to protect specific equipment. Proper overcurrent protection is crucial. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when too much current is drawn through a circuit. Short circuits occur when there is a direct connection between two conductors. Overcurrent protection devices trip or blow when the current exceeds the rated value, interrupting the flow of electricity and preventing damage to the wiring and equipment. The NEC specifies the requirements for overcurrent protection. The size of the overcurrent protection device must be matched to the ampacity of the wire. It's important to use the correct type and size of overcurrent protection device for the application. Electrical safety is paramount. Working with electricity can be dangerous. It's important to take precautions to protect yourself from electric shock and other hazards. Always turn off the power to the circuit before working on any electrical wiring. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it's best to hire a qualified electrician. An electrician can ensure that the electrical work is done safely and in accordance with the NEC and local building codes. Remember to always consult the latest edition of the NEC and local amendments for specific requirements in your area. Local authorities having jurisdiction or OJs may have additional requirements or interpretations that must be followed. Stay informed about changes to the electrical code. The NEC is updated every 3 years, and it's important to stay informed about the latest changes. Changes to the code can affect the way electrical systems are designed and installed. You can stay informed about changes to the code by attending training courses, reading industry publications, and consulting with electrical experts. Maintaining an ongoing awareness of electrical safety practices and code requirements is essential for ensuring the safe and reliable operation of electrical systems.